difficult to.
Good afternoon, security community, and welcome back to mWise. We're here up over 5,000 feet in Denver, Colorado, midway through day one of our power-packed coverage of the event. My name's Savannah Peterson, delighted to be joined all week by John Furrier. John, we're keeping our hands toasty in our little mugs right now.
I mean, it's so hot in here in cloud security, but cold temperature-wise. And, you know, our next guest is on last year.
Is this liquid cooling or liquid heating?
Yeah, liquid heating, yeah. No, that's for the GPU one.
Couldn't help myself there.
Anton has a great guest. He's got great perspective from the CISO office. And to me, he's got a good view of the landscape within Google and outside. You know, securing by design, intentional refactoring the infrastructure and application space is really part of it. So looking forward to this segment.
I know, without further ado, Anton, welcome back to the stage.
Perfect, thank you.
A CUBE regular. You've had a very busy day. Thanks for making the time.
Being the number 2 or the number 17, so like let's hold on with the regular label, but we'll see.
We're starting to develop a pattern. We now have 2 data points, which definitely counts.
Regular.
You've had a busy day so far. You gave a presentation earlier talking about the cloud security paradox. Tell me a little bit about that.
So it's a paradox, but it's also my obsession, because we have from my analyst days, Gartner days, there was this line that every analyst knew: cloud is secure, but clients are not using it securely, and that most breach is a customer fault. There are two sort of well-researched, well-founded lines, but they're also kind of interested and kind of I want to argue with them, because they're true, but they're also kind of, as somebody said, blaming. They shift correctly the fault for some breaches to customers. But why is it the case? What can we do so that customers use cloud securely? We build secure infrastructure, we get that, but cloud use is not always secure. So I wanted to distill it down to a framework that people can use rather than just, talk about this. We want to have something that improves the client side of the shared responsibility matrix, not just ours.
I think that's actually really important, and I think the blame game is quick to happen when it comes to breaches and anything else that happens. How do you help customers figure out how to, or who to blame?
So I think that it may not be like a really hot take, but remember the Snowflake debacle recently. The really interesting thing about this is that the media coverage of it really split into two pretty clean buckets. One bucket basically thought it's a cloud provider breach, even though it wasn't, and the other bucket claimed that it's a customers. But in this case, the shared responsibility model kind of came to life, because it was very clear to me that some people unambiguously attribute fault to one side, but another group attributes fault to the other side, and they almost talk past each other. But it indicates that the underlying problem of responsibility and who secures what is unsolved. I build a cloud, I give you MFA, you don't use it. You get hacked, who's at fault? Well, it depends who you ask. How about I make it very easy for you to use MFA, and you still don't? Well, maybe that shifts the fault a little bit to you. Okay, I made MFA mandatory with a very difficult way to turn it off. You still turn it off. You get hacked. Like, to me, there's subtle currents of responsibility that are different. So we want to build the cloud in such a way that most use is secure, or as my boss Phil Venable said, inevitably secure. This is much harder than building secure cloud as a provider. Building secure cloud use, enabling secure cloud use is way more tricky. And that's what I'm trying to explore and distill into something usable.
I love the reference to Phil. I sent him a note earlier. He's not on this year, he's on last year. Called out in the keynote by Kevin. And I want to get your thoughts from what Kevin said in the keynote around that point, around accountability. He said, quote, "It's about who accepts the risk." And this is the big question about accountability. How does that translate into the cyber? Because if I raise my hand and say, I own it, who owns what? This becomes the question, because it's a risk management at the end of the day, on one hand, but data on the other, and then a lot of complexity in a distributed computing environment. So it's a hard question.
It is a hard one.
What's your thoughts?
I want to start with a somewhat related joke that I think I've tweeted a few times, and maybe now it's time for another one. There's a category of security leader that has this view that they would accept the risk for as long as it doesn't happen to them. But of course, it kind of defeats the purpose and of course breaks the definition of accepting the risk. To me, with cloud, the genuinely questionable part is whose risk is it to accept? how are you making it easy for the other side to manage the risk? So if I give you the product that's very, very difficult to deploy securely, and you decide to use it, did you accept the risk or not? Or did I push the risk to you and like wash my hands off it? Now, if I made a product very easy to secure and I provided guidance and tools and, a little AI chatbot that says you do this, don't do that, yet you decide to go absolutely the opposite, click through 5 warnings, don't ever do that, and still did it, then you clearly accepted the risk. That part is much more unambiguous, but there are a lot of gray area where it's already clear when you accepted the risk.
Yeah, Taylor,
great point.
Taylor Lehman brought this up on the previous segment. I want to double down on that because when I brought up the notion of supply chain, we all talk, it's in the hardware, of course, silicon, data, supply chain, now you got agentic systems. But he brought up an interesting point when I brought up third-party applications. Now you have third-party connections where data is going through APIs. Kind of rolled his eyes like, okay, that's a long conversation.
Yes.
But it brings up the whole accountability. His big point was, people say they're secure and they're not, or they fill out some mechanism, checkbox. And he was big on that, and I'm with him on that.
Yeah.
So how do you talk to customers saying, when you deal with third-party partners, is there due diligence? Is there a mechanism? This is a big point, and this is not talked about much, but what's your reaction?
My reaction is, while it sounds complicated, it's actually a lot more complicated. And here's the example from again, accepting the risk. I use a SaaS provider for some business process. There is a shared responsibility model. SaaS provider does this. I do this for security. But the SaaS provider backends to IIS. There is actually a 3-party model. And the IIS may use partners, may use contract developers. You may have other things connected to an API. In many cases, it's a lot harder to even point a finger and say third party, because I can say, you build this application for me and data got stolen. And they say, oh, it's stolen from the S3 bucket. And I'm like, you are a different company. I don't have this cloud relation. I have a relationship with you. And they say, not our fault, it's them. Like, that's a much trickier one. So
very porous.
Yeah, it's
the responsibility.
Yeah, it ends up.
Nobody wants to hold the responsibility in that case.
This is the end-to-end workload. This is the end-to-end workload argument.
Yes.
Can you go end-to-end with observability type, maybe not specifically, but management technology?
Yeah.
This becomes a really interesting concept.
Yes.
And this brings up the role of frameworks, because we're hearing, again, there's like more frameworks. NIST is doing some great work. Woke is doing some great work. The Open Foundation. So you're starting to see standards bodies getting highly involved. Quantum, NIST is doing some good work on that piece.
Yep.
Oh yeah.
What's your take on this? Because now we have to solve this problem. What are customers doing with that right now?
I mean, to me, when frameworks exist for many of these things, so I'm not a post-quantum kind of guy. I don't really do encryption. But as far as frameworks, to me, one thing that before you apply any kind of framework, whether it's supply chain or traditional kind of guidance for security, you should have at least all the parties and all the components should be on the table, because it's not enough to say, this is the approach between you and me. I mean, I don't want to have an unknown third, fourth, fifth, whatever other parties. So to me, visibility implies you actually see all the pieces first. I mean, people sometimes argue about, do you have all the assets in the cloud? You can call an API and you know all the systems. You're not going to have a server in a closet. And people say in the cloud, asset management is much easier. But at the same time, somebody can whip out a credit card and buy their own cloud. And so in your cloud, you know all the assets, but you don't know that your business actually has this other cloud.
Yeah.
So to me, frameworks do rely on a very robust asset management, and it's not very 2024 cool security advice, but it's something that makes the rest not very workable unless you know what you have in the cloud and which cloud. Most of the rest of the stuff can't be applied.
Well, and you can't build secure things on top of that. I mean, the visual that's coming to my mind right now is, you get a Lego kit and you pour out all the pieces to kind of do your inventory and make sure you have 4 of this and 7 of that or whatever, so you're not going to end up in a place where you built it and it's not going to work. I mean, it's not.
Or you have pieces Lego from a bottomless box.
Yeah.
Right.
You don't really know what would show up, and you can't really finish because who knows what else is in there.
Yeah.
Yeah.
So building on the Lego analogy, let's say we built our Lego kit, our creation, our Lego server for this moment. There's a big myth around set it and forget it. I can't just leave my little Lego server alone, right? There's going to be an adaptive threat landscape.
I mean, yes, and given that most of my time I spend in areas related to detection and response, I also sometimes have to argue with people who say, if you build things in the most secure by default, secure by design manner, everything is in infrastructure as code, everything is pipeline, verified, validated, then runtime stuff can just be left alone. And I kind of usually recoil in horror and say,
Yeah.
no, just because you do your stuff on the left, shift left, 10 times better than everybody else, it does not mean you have to get to drop the runtime stuff. Like, you still have to have DNR, detection and response.
Right.
So to me, improvements in how you build, how you deploy, all help, all reduce risk, they're all great, but none of them removes the need for observation, for detection. To me, there's no amount. You can switch your investment from $1,000 to $1 billion. You're not gonna then have zero in DNR. To me, that's like a law of the universe.
So talk about the evolution of endpoint protection, because you bring up some good points. Is that state of the art now? Is that where the action is? Because now the surface area is increased. You got training poisoning, with the Gen AI, you got prompt injection, which everyone talks about, but the training was even bigger. And then all this stuff around data is key. So that you start to see more areas getting very porous. So is there even an endpoint?
This is where, so I don't want to boast, but some of you know that I coined the term EDR back in 2013. And this started the kind of how, let's do EDR, let's deploy more EDR. And then over time, people started thinking, what other domains are there for DNR?
Yeah.
And I mean, for cloud specifically, if you do EDR, it implies you have an E.
Yeah.
But it's debatable. It may have APIs, you may have containers where EDR sort of fits well, and you have serverless where there's no E, and no amount of EDR in would make you better. There's no E, you undeployed. So people are trying to invent all sorts of related tech, like cloud detection response. There's somebody who showed up with data detection response. There's also a recent movement to do ADR, at application detection response. And they're all kind of trying to fit in the new reality of cloud, where there's no E.
So endpoint detection and response, EDR, makes sense when you're attaching or connecting.
To server,
Congratulations. I didn't know you coined the term, but that's good trivia, and we're in honor of a legend.
Right.
Thank you for sharing. But it's situational, because if you take the E away, it's something else. So
it's situational. Something else.
That's what your point is.
Yes, that if it's a cloud application that doesn't run on any servers, virtual machines, EDR is NA, not applicable.
Okay, so what's the new term you're going to coin now?
Oh, I'm not at Gartner anymore, so I don't really do acronym machinery anymore. But I do make fun of other people acronyms, because, of course, 5-letter acronyms to me are big no-no. Don't do 5-letter.
3 is the number.
3, and if you really push it, 4, but 5 is to me a bit of a
yes.
At that point, it's a word.
You like sassy? You like sassy? No, I'm not a big fan of sassy.
I'm not a big fan of sassy, but I mean,
the name at least.
The name is very sassy, and I think Neil is a great analyst who coined the term.
Yeah.
But at the same time, sassy has confused quite a bit of people, because like zero trust, sassy there's also sassy without an A, right? There's a C, which makes it all very fun to watch.
Okay, to simplify it for the people watching, how do you build the secure next generation environment? Because when we look at the data from the keynote, they need solution strategies. They don't need another product.
Yeah.
Well, they need it if they need it, right? So it's not like just buying what they can, even though they still do that. What are successful strategies that you prescribe or you recommend or would put on the table for customers?
So this question has a certain fork in the road that happens very quickly. There are customers who sort of insist on largely traditional, what I would call 1990s tech stack, and almost certainly 1990s processes. If you ask, can I achieve this amazing results in security while keeping this? The answer is actually no. I think it's almost like I want to transform as long as my life stays the same. Not a thing. You can't do it. The answer is no, there's no answer. So the challenge is, how do you transform in a way that fits your org? How do you adopt modern stack and also don't drag old processes? There's somebody who brought up an example of containers being part of the modern tech stack, and how people often as SSH, remote connection to containers. And I was like, no, that's from the old world. Containers are deployed through pipelines. This is how you do all this stuff. You don't connect as an admin to a container. That's not a thing. And they say, here we do, and whatever environment.
Yeah, they did it wrong.
Because the old practice,
The legacy.
yeah, the old practice and people converged with the new tech, but the result is then old.
Right.
So like old process plus new tech, result is old.
So the foundations are built on
Yes.
the wrong foundation.
Yeah,
You got to read the foundation.
But changing tech is easier.
Yeah.
So then
Yeah.
you almost tell people, you shifted from servers to VMs to containers. That's great. But your IT is kind of still 90s DNA IT. And so a lot of solutions we have for you won't fit.
What's your take on the cloud native? Because we're going to be at the Linux Foundation event. Kubernetes is getting boring. And that's a good sign, like Linux.
Yeah.
What has to happen in cloud native to bring in this next era of data-driven threat detection, intentional design, secure by design, platforms for security?
Yeah.
Are we almost there? Do you see us kind of, because there's a runtime piece there with
Yeah.
Kubernetes,
Yeah.
and you got pipelines, all kinds of microservices.
But adoption to me is not, I mean, adopting the tech without adopting the modern processes to me is where it breaks in most cases. You can be, and my Kubernetes and connection example is there, but there are also many other examples where somebody adopted the tech stack but didn't adopt the process that the designers and inventors of the tech stack assumed. It's almost like you look at DevOps or SRE at Google and you look at tech stack and you say, tech stack I like, but I want my once a quarter change management report kind of process. And like,
Yeah.
they don't mix.
It's a disconnect,
So to me,
yeah.
the process culture part is hard, and I want the more evolution there. I think with tech stack, we are way better than before. Culture,
It's like the dogma. They're used to their ways. It's hard to change. Shifting to kind of that data analytics and the data-driven insights into threat detection brings up the question that we've been talking about all week. I wrote a research note this morning about this. The gap between security and data teams. Now, the history was security teams are security teams. We know what they look like. We know and love them.
Yeah.
They're doing their job within a lot of chaos, but it's really well known. Data scientists used to drive all the analytics, but now the data engineering roles emerging out of the platform DevSecOps side. So that's an infrastructure kind of thinking.
Yep.
So these are coming together. What's your thoughts on that? Because that creates an opportunity, but also to your point about dogma and pre-existing views.
Yeah.
What's your take on this?
I think that in the past, kind of in the old times, a security team and data team were connected maybe through DLP or through some other data security, maybe key management, encryption. So they were sort of data security tech that had to be the connection tissue. But in the data security and data being processed and analyzed in a bunch of new ways, a lot of old stuff doesn't fit. So technologies that showed up that are called DSPM, data security posture management, are kind of attempts to modernize the data security to catch up with data. So like data evolved, but data security was kind of like not quite fitting, and right now it's trying to catch up. That's my impression. I deal with it a bit less than before, but I feel like this is the same example of security catching up with IT and business, like our bane of existence, right?
I mean, at the end of the day, you start to see the pattern. We talked about it earlier. Storage companies rebrand, call themselves cyber resilient. They go public like Rubrik. I mean, security is a data challenge and risk management.
Yeah.
It's still on storage. Okay, I'll call myself a security company, get better valuation. Okay. Yeah. But we hear from the keynote from Kevin and also here from the experts from Google, resilience is a hard thing to measure because there's different scopes and perspectives of resilience.
Yeah.
How do you look at the resilience kind of like equation? How do you test resilience, stress testing systems under critical scale? Or how do you get that resilience? Is there a formula? Is there...
How do you quantify it? What's the metric? What's the metric for resilience?
Definition and
so,
metrics.
There's a kind of incredible amount of work going on at Google, and of course Phil participated in the PCAST report on resilience, cyber physical resilience for critical infrastructure. And one of the things that came out of this report is the 10 indicators they have for kind of like exploring, deploying, expanding the scope for resilience. And we're trying to attach metrics to some of them, because you're right, some of the stuff is very practical, but hard to start. Like you say, I want this to be independent of internet connection failures. Great goal. how do I do that? How independent am I really? You don't want to be that person, that ransomware victim whose backup relied on Active Directory, which was ransomware. So the result is I can restore from backups. Yes, backup server calls identity, and identity is encrypted by ransomware attackers.
Right.
So you kind of can do it, but you can't really do it.
Yeah.
So to me, this is like a circular dependency for reboot. Like there's a science and there's a craft for doing it not that way, but it's a lot harder to explain and measure, and this is what the PCAST and similar work by various consortia is focused on.
Yeah, you're the first person that brought the word craft into this. I think that's important. This mechanism.
It's not all science, it's so much of it is craft.
It's like crafting, you gotta put a little art and science into it.
Yes, it's art isn't
not art,
but I mean that's why I kind of say science and craft.
Creativity.
Yes, creativity for sure. Yes.
Like, knowing kind of like how the world, my systems work.
Correct,
like,
correct.
Not the playbook.
Well, and where the data is coming
Just
from.
playbooks. Yes, correct.
Yeah, and with all the increase in data, you've got different sources of things coming into that ecosystem. So
correct.
Yeah, it's a whole can of worms. All right, you came up here and your energy was very zesty, and I appreciated that right away. So I'm going to ask you two closing questions.
Sure.
What excites you the most about our security future?
So I'm going to give you a two-part answer. And one is kind of conventional, honest, conventional, and the one that makes my PR people happy, which is, of course, AI. I do see a lot of fun things, a lot of innovation down both using AI for security and securing AI. A lot of my daily work connected to sort of talking to clients about securing how they use AI for business, secure AI usage. There are certain parallels from secure cloud usage to secure AI usage. But to me, distilling the novelty of securing AI and learning those lessons, learning the mistakes is very fun. And I think to me, this is not just about, can I have the AI firewall? Yes, actually, you can have an AI firewall. But you can have this other stuff that some of it is different, some of it is similar, but to me this is very interesting, very novel. Startups, big companies, us, AI designers, customers, there's a lot of innovation and a lot of it solves genuine problems. So AI to me is fun. Some people say it's a cliche, some people say it's starting to slide off the hype cycle. Yes, very true, but there's still a lot of really interesting, insightful work. And to me, the second part is actually this bit that I brought up about secure use of cloud. Because we still have people who have going through transformation and all that stuff, and you sort of assume it's AI, but when you talk to them, you realize they're actually transforming to cloud, which was one of my moments. I was assuming they mean AI, but they actually meant cloud. They're in the previous revolution. So a lot of this is still not a solved problem.
Yeah.
And there are enough companies that are sort of exploring how to modernize and move to cloud, modernize security operations, modernize other things, and also move to cloud. A lot of this does call for a lot of interesting and new thinking, not just, hey, here are some fresh new tools, version 2, or deploy them. It's not like that. A lot of this is culture change.
I think that's a really good point. And communicating about priorities and why that needs to happen as well, which is a big part of why people resist change. All right, last question for you. Now I'm actually curious what you're going to say this. What do you think is the most overhyped thing in cybersecurity?
The most overhyped thing in cybersecurity. There's a lot of competition for this title, and it's kind of more of a probably a better RSA question than mWise question. Ultimately, I would still bring up AI because I feel like in the using AI for security, we are in the use case search phase. We are looking for areas where Gen AI delivers results. And as a result, when we go on a use case hunt, we collectively, we see a lot of use cases that just don't work. But people who have a very bizarre optimistic take that Gen AI will solve almost like every security problem. To me, they're wrong. They're solid, robust use cases, but if you do this, not that, you're going to be disappointed, you're going to have disappointed clients. So to me, Gen AI for security is probably overhyped, but at the same time, there are very good, solid use cases where it delivers magic.
So maybe in next year you could do a talk on AI by design.
AI secure by design is kind of now, not next year. So I think it's more,
A follow-up. Wow.
Good job.
Awesome. Anton, this has been a really exciting conversation. You brought the heat. We appreciate it. I'm actually physically warmer than I was sitting here 20 minutes ago. So
well, this is very fun. I mean, that's kind of why we do it, right?
Yeah.
It
Thanks for sharing.
is.
Appreciate
Yeah, no,
it.
we appreciate it. Thank you, John. Always insightful with your questions. And thank all of you fabulous cybersecurity community individuals who are tuning into our 2 days of live coverage here in Denver, Colorado at mWise. My name's Savannah Peterson. You're watching theCUBE, the leading source for security news.